if I ask you to teach Kubernetes to the people, is a how do you take that challenge, or how you look at this challenge of teaching Kubernetes to others?
Yeah, I love that challenge. I do that challenge every day. And that's like
Wonderful.
why I took the role at Amazon was I liked being able to teach people, but I like teaching people in slightly different ways than some people. I like to teach the way I like to learn. In a lot of cases, that's with props and that's with visual aids and that's with whiteboards. And I like to draw things. And we have a show at Amazon called Containers from the Couch. And my
Yes.
team we have guests come on, we try to teach different Kubernetes concepts. Most of the shows that like if I'm in charge of teaching it will have some prop involved, and I'll bring in something for a visual aid because that's how when I thought of it, I'm like, how does security work? It's like, okay, well, how does a door lock work? That's secure, right? Like that's like for me like a physical like thing. So how would a door lock be similar to RBAC? And I'm like, okay, well, how can I tie these things together and make it more easier to understand for people? And I remember doing I did a Bottle Rocket episode, and we were talking about upgrades. Like, how does Bottle Rocket do this like partition swapping for like how it boots and stuff like that. So I had like bowls of cereal and two different types of cereal. Like here's the new version of Bottle Rocket, here's the old version. And as we pour it on either side of the bowl, like that's when it actually like flips over and we boot to the other side. I think it was like Cheerios and Fruit Loops or something. But to me, like that was just how I liked to learn things. I love
For joining us today on Cloud Native FM podcast, episode number 29. And been in the past, I have guests from Microsoft, Google. Kelsey Hightower has been in the show as a developer advocate from Microsoft. We have Thomas Maurer, he's a developer advocate for the Azure team. But no one, literally no one from AWS till today. I am joined by developer advocate at AWS, Justin Garrison. And today we are talking about AWS, EKS, Kubernetes, container, all things around AWS. Thank you very much, Justin, for joining me today. So introduce yourself to my audience, and thank you very much for the show.
Yeah, thanks for having me. I'm really excited about this. I've been at AWS for about a year and a half now, and I've been a user of AWS for many years before that. So I'm coming from definitely a customer perspective of how to use AWS, how to run infrastructure and build apps on top of it. And then now at the other end, it's great because I was able to do it so much that now I get to tell people about it and teach people that are on their journey learning, or even advanced users trying to do something new. So it's a lot of fun for me.
Yes, absolutely, absolutely. Yeah. So I've been following around like since then I meet you on the Twitter side of things and see someone from the tweeting about the AWS side. So it's been a literally, and everyone who go follow Justin on Twitter has been a wonderful trainer around Kubernetes and these kind of stuff. So today's agenda were about the whole container ecosystem in the Kubernetes landscape, as Kubernetes is making the market on clouds really are jumping into the Kubernetes, and they spun up their services around like EKS from the AWS. So tell us about what is rightly happening inside EKS in AWS team, and what's you're most excited about in the AWS when you first joining a year and a half ago.
Yeah, I mean, I've loved containers for a long time, just how many problems they solve for me on the infrastructure side of, setting up servers and giving people SSH access and like, how do we get apps to it? Like containers solve so many problems for me there that it was really fun just to see as orchestrators were coming out and becoming a thing to like, oh, originally I had, a dozen containers with a couple servers and we just kind of put them on there by hand. And then once I got past a certain number of containers, like this isn't really maintainable anymore. I have a spreadsheet that tracks like which server has which apps and which containers are running there. And so we needed something more. And doing that in a cloud environment was obviously the next step because all the infrastructure is API and I can just say, oh, I need another box, but then I don't actually have to do it, right? We have software that does that for us. And that was a great, Kubernetes has been around for a little while now. Mesos and Nomad are also in that space. They're just like, let's just get apps out there and solve business problems more than just like the technical, like it's shiny, it's really fun to learn, but also like we're getting paid for a day job. And like in a lot of cases, we need to solve some sort of business problem out of this as well. So with EKS, it's giving people just like, let's set up Kubernetes for them and give them as much of, raw Kubernetes in AWS with all the integrations you might want for AWS. If you want to talk to, use pod IAM roles, if you want to talk to, internal AWS services, all of those things exist in this space that make it easier instead of running it yourself. And things have existed in the past to do your own Kubernetes. Kops was a really popular deploy Kubernetes on top of AWS and did some of those integrations, but it was always kind of tacked on as like open source tooling that needed to evolve and then adopt for more things in AWS. And being an AWS native service with a team, people at AWS that know how other services are changing, what integrations are coming, how we can integrate more with other teams and other services allows us to make that integration just deeper for people that say like, no one uses Kubernetes in a vacuum. They're going to have load balancers. They're going to have EBS volumes. They're going to have Kafka stream, whatever. Like we need to be able to allow them to do that easily. And the smoother we can make that ability to say my application isn't just an Nginx pod. Like that's not typically what's solving a business value. We actually have more things to it. And so we need to be able to make that easier for people to use. And that's what we've been striving to do for a long time. And this past year, we've been doing it in more places where EKS Anywhere launched in August, which is allowing people to do EKS style Kubernetes on-prem. And we say, okay, we've learned a lot by running a lot of Kubernetes clusters. We know where we hit performance bottlenecks. We know the architecture that we want for Kubernetes. So let's put that on-prem for people. And lots of people, you can run Kubernetes other ways on-prem. My first time running Kubernetes was, I just ran the hypercube binary, which was this fat binary that run all the services. I was like, I'm just going to shove that in systemd and we're good. But it wasn't super maintainable. It wasn't something that I could get support for. It wasn't something that I could evolve long-term. And in this case with EKS Anywhere, we're saying, hey, actually, we know we've been running this long enough. We have enough versions of Kubernetes. We know how to maintain it so that it's easy to transition, to upgrade, to make it highly available, all the stuff that a business needs. And that's really, I worked on that for quite a bit this year, which was a lot of fun.
Yes, absolutely. I think wonderful topic you're addressing. I think the EKS Anywhere is a wonderful kind of a service because as a user, I am in the let's say in the on-prem data center. And I want Kubernetes, the EKS cluster I know about. I see the community and the features in it should be great. But I am reluctant in going to the AWS or any cloud. So I want this to be integrated into my on-prem data center because there are some organizations, they're limited to not use the public cloud or some kind of thing. So if they can bring in the EKS in their own premise data center, I think that's a wonderful news for those people who are shy on using the public cloud. So I think that's a great news. And also I think they tell us about the Kubernetes around the features because people are talking about, because some of the cloud provider are kind of they're using the Kubernetes and make some intelligence decision on top of it. So in the Amazon AWS on EKS side, do you guys are also doing some kind of bring in more intelligence to the Kubernetes, or it's just a vanilla Kubernetes and you are using that and making the Kubernetes as easy as possible for the end users?
We definitely make it as Kubernetes native vanilla as possible. I mean, all the Kubernetes we run are conformant to the CNCF guidelines and tests to make sure that anything that's Kubernetes could run in an EKS cluster. Because that was the thing that if we tried to make this a special type of Kubernetes or something, like it's just not going to work because the ecosystem of Kubernetes in cloud native is so big that we couldn't just say like, oh, well, we're going to solve this, 80% problem or something like, but that's leaving 20% of people like, well, I want Kubernetes. And it's, yeah, well, like we want to give Kubernetes to as many customers as possible because that is the thing that a lot of people want, and not just the Kubernetes piece. They want the ecosystem. They want the rest of what they can do with Kubernetes. And so we give them that, and we build that on top of EKS distro is like our open source bits of Kubernetes. And that was early, last year we decided that we needed to open source this. This was something that we were running EKS clusters on upstream Kubernetes with some patches, with some additional, sometimes it was features that got pulled in early. Sometimes it was CVEs, sometimes it was other patches that made Kubernetes easier for us to run at scale. And that's what we build EKS on. So we open source EKS distro and you can run those bits. Like it's the same bits that we pull in for every EKS cluster, and you can run it on your local computer. You can use a kind cluster with EKS distro. Like the functionality is all the same, and it's open source, so you can see exactly what we're doing for patching that stuff. And we said, hey, we have this open source thing in EKS distro. We're going to also use that for EKS Anywhere. We use it for EKS. We use it for anything that we're running with Kubernetes, because it's consistent everywhere. And it's not like, oh, well, that version or that build flag or something was different on this binary versus this other one, because that also happens to some people where they're running a special version on-prem, they have a different version on their laptop, and they have a different version in the cloud. And that just doesn't work, because you're always going to get some variance across different versions or builds. What version of Go built the binaries, that sort of stuff all comes into play when you run that many different clusters in that many different locations.
Yes, absolutely. I think that last year of 2020, the Amazon E-Rain, when they announced the EKS distro, and the wonderfully you described the whole scenario, what the use cases it's fit for. And tell us about the open source stuff that we are also talking about a lot on the community side, on our Kubernetes community on Twitter. We're talking about so many stuff there, like Prometheus, Grafana, or we can Linkerd service meshes. We'll talk about the GitHub scenarios, the Knative project. There are a ton going on. How the AWS teams are looking at these open source projects on the level, because I see they have announced the managed service as a Prometheus we can use on the AWS side of things. So how the AWS community is looking at these open source projects, and what's we expect from this reinvent and the moving forward? What we expect from this?
Same thing we've always been doing at AWS. Like, we listen to customers, and like that customer obsession comes into play every time. And someone says, hey, I have this Kubernetes thing, but I also have to run Prometheus, and I also have to run Grafana. It's like, oh, well, last year we launched managed Prometheus Grafana. We worked with Grafana Labs, and we said, hey, we'd like to run this as a managed service for customers. And they've, every time I talk to the Grafana folks, they love it. They're just like, yeah, this is great, because it gets more people to use Grafana and so many different ways that they can just tie into it, and they don't have to run it. It's not, I used to run Grafana, I used to manage Grafana. It was never like the worst, like hard app to run, because it was a great operational app. It was a single, container. I just ran it. I added my config. That stuff I loved, but it was a little risky to like upgrade, and a little risky to like change some things, because so many people started depending on it. And with managed Grafana, a lot of that stuff, again, is just taken care of for you. So it's just like, oh, I can still add my configuration. I can call it AWS API, and it just runs. And then all of my Kubernetes, logs get scraped by Prometheus and automatically are linked into Grafana, which is just a great experience for someone that's just like, I have Kubernetes, but I want to see it better. I want a better dashboard. And Grafana also has like a cool website that you can just import dashboards. There's like an ID, and you can just say like, oh, give me that one. And there's Kubernetes dashboards out there. I used to love those when I was first starting with Grafana, because I was just like, I didn't have to fiddle with every pane and every source and all that stuff. I was like, I had Prometheus, I had a metric server, and I just pull in a default dashboard, and it was great. But the rest of the open source stuff we have, like EKS Anywhere, I was so excited when we were doing that all in open source, because you don't need an AWS account to even run it. Like, you can just go download it, try it locally on your laptop, and never do you need to talk to us as AWS. It's just like, you could just go do that and try it. The load balancer controller I helped with a little bit last year too. And that's another big one where people inside of AWS, you can get a native, expose a service as a load balancer, but it's always like, there's not a lot of features to it. It's just kind of the default inside of Kubernetes. But the load balancer controller, you can do a lot more. ALBs, ELBs, NLBs, like whatever layer of TCP you want. And also all sorts of settings for things like you can share load balancers for multiple services. So you could save costs on the load balancer end. You could do, a lot more annotations and features that are native to AWS in that controller. And again, it's just the ecosystem of Kubernetes is so big. It makes absolute sense that we run over here that you can't have. And even all the way down the stack with BottleRocket, right? We have BottleRocket as an OS that is a container native, Kubernetes native OS that runs just containers, and it's very stripped down to be very, performant and security conscious for anyone that's like, hey, you know what? I don't actually want to upgrade this OS. I don't want to manage it. BottleRocket, again, open source OS, you just throw it in there. And we just last week announced managed node groups now support it. So you can just say like, I want Kubernetes, managed node group, BottleRocket, and you don't have to worry about your nodes, needing to upgrade. You don't need to worry about the OS, security wise, because we can secure that at the OS layer with SE Linux and, everything that we're doing at that level, all the way up the stack through Kubernetes, which I think is just fantastic because it's all open source and available.
Yes, absolutely, absolutely. I see from the community, they are looking at the very actively. A lot of the people that joined the AWS team recently, they are from the open source communities. Like I see from the Phil Estes, he's been the core maintainer of the Kubernetes container D team, and he's recently joined the AWS team. So I think they are really looking after to these open source tools and wanting those people to be in their team and do heavy lifting for us. So as a user, I am using the Kubernetes, my own like a Kubernetes net shelf, the core Kubernetes. I am figuring about how the kube scheduler or controller manager, API server, etcd. I'm thinking about all of the time if I'm using Kubernetes myself without the cloud providers. I'm thinking about a lot about the worker nodes group a lot. But when I use the Kubernetes in the cloud, so they hide the way the control plane from me. So share some thoughts, share some best practices around. As a customer, what are my responsibilities then? Because they are hiding away the control plane from me. I end up lefting with the nodes and apps on top of it. So what are my responsibilities then if I'm using the EKS or any public cloud Kubernetes?
I think those responsibilities have changed, not just Kubernetes. Before then, right? Like we had VMs and I had like a physical server that I knew where it was in the rack and I could go plug in a USB, keyboard and a monitor and I could look at it. And you move to AWS and you lose the physical server. Like no one's allowed in the data centers. Like I've never been, like, I don't know. You can't go there and like go plug in a USB and like go look at it. And so like the responsibility shifted there where I'm like, oh, guess what? Like I don't have to manage the BIOS. I don't have to manage like RAID controllers. Like that stuff just went away. And then it's like, okay, well now you get a VM, you get a VM interface and you can still see things from that. Like we have, console output from VMs that you can see, watch them boot. You can see all this information about them. But you don't have like physical access to like DOM0, the hypervisor below it to like run commands and say like, oh, well, I want this to do something else. And you call an API for that. Shifted again into Kubernetes as well, where it's like, hey, I used to have the etcd. I used to have access to etcd and I would do bad things to etcd. And I didn't actually want access, but I needed it because I didn't understand it or I didn't know how to do something or I like critical fix or whatever. Like I didn't make a backup properly. Like there's all these reasons that like I needed etcd in the past. And those reasons are getting smaller and smaller, just like I don't have reasons to have a physical server anymore. I don't have a lot of reasons to have an etcd cluster at my disposal. And so at that point, like Kubernetes is moving up that stack of like, well, actually you don't need the VMs, you just need the Kubernetes API, right? You need the API and you need a couple controllers that exist. You can, if you don't want to use the default scheduler, right? Like you can actually apply, annotations to your workloads and say like, oh, I want this other scheduler to run, or I want to run, you can run your own like Kubernetes scheduler separate inside your cluster and have that talk to the API and do your scheduling for you. If you really need to like pull some of that stuff out, you can. But etcd and the actual, API server, those are just managed for you. And you don't need access to them to be able to use Kubernetes. If you really need to, again, plug into it, EKS-D, EKS distro is open source. Like you can go download it, you can run it locally, you can see what it's doing and even replicate some of that infrastructure in another environment and say like, okay, well, what would happen here? What would happen with this thing? And if that's really like the level you're at, you might not need Kubernetes. You might need VMs. Right? And that might be the case where you're just like, I have to do this myself. And then Kops is a great option. You say like, I have to run a fork of Kubernetes, right? Like we have people that literally need to run, patch Kubernetes for various reasons, and they have to run forks and they can't run EKS with that. And that's okay. They can use Kops, they can use EKS distro, they can use another installer, just use Terraform, EKS distro bits and run your own fork or whatever. And you can still run Kubernetes with the access you need. But if you want the managed solution, if you want automatic upgrades, if you want, secure isolation for every cluster, all that stuff, like we'll give you that on the managed service. And so that's one of the benefits there. But yeah, the trade-off of responsibility of like, I don't need the physical server. I'm not responsible for it anymore. You don't need etcd if you're using Kubernetes, so you're not responsible for it anymore. That's on us. And so that's like those trade-offs of where are you focusing your time and what are your actual needs for your applications and your infrastructure.
Yes, absolutely. Because cloud is always a shared responsibilities, and if you are already using the public cloud provider, they're expecting from you the shared responsibility model, and then you use Kubernetes as a managed service. It's mean you are understanding the shared responsibility pattern already, and that's when you are using the EKS and EKS side, I think. So another question that arises all of the in my mind, that EKS, what sort of the networking solutions or the container runtime, shed some light on the underhood of the EKS, like what are the networking solution or the storage solution or the container runtime interfaces EKS using under the hood, and they're not hiding away from us all of these details. So tell us, sir, about the container runtime and networking solutions around EKS.
You broke up there for a little bit, but I think I got the gist of the question. Can you hear me?
Yes, absolutely. Go ahead.
Okay, just making sure. So I think the integrations at that, like we have a CNI, a networking interface that ties directly into VPC. Like that's the default for EKS because we know you're running that in AWS and we can give you the best experience with direct VPC connections. Every pod is getting an IP address directly from within your VPC. And that's been however their VPC set up, however their subnet set up, they don't have to worry about that other layer. Where a lot of CNIs are very universal and they allow you to say like, oh, we'll just add this pool of IPs and float it somewhere in this cluster, right? Like I'll have another database that stores that and then routes it within the cluster, which works great. And if you want EKS clusters as well, you just take out the VPC CNI. And we've been trying to do a lot of improvements on VPC CNI for things like we recently announced prefix delegation, which allows you to run a lot more pods per node because you can say, hey, I want to /22 on this node, and it just takes care of all the IPs. So in your route table for your VPC, it says, hey, anything on that /22 goes to that node, and it figures it out at the at the node itself in Linux. It's just doing route rules. And so it says, oh yeah, I know where that is. And it ties them into the virtual, the virtual NICs on the pods themselves. So you can get some of those things of like high density, which is usually the thing that a lot of people say, I need a different CNI because I need to have 200 containers per node or something, or a different CNI because you could add another pool. You could, the whole cluster could have a /12 or something. It's just like, oh, I just want all the IP addresses because it's gonna be a giant cluster or something. And in this case, VPC CNI, we're trying to improve a lot of that stuff where we say, hey, some of these limiting areas of ENI, a network connector inside of the VPC needs to be assigned to this machine. We can have warm pools of them. Like there's a lot of things we can do to improve the performance. But it was one thing that I always remember people saying when I was a customer, like, oh, well, I can't use VPC CNI because I can only get, 20 pods per node or 50 pod, whatever it was. And it's like now with prefix delegation, we're allowing that to just happen. And we're working on IPv6 support as well. So once IPv6 support's there, you actually have seamless like IPv6 on the pods that go out to an IPv4 address. And I was like, that's amazing. Like you can actually just translate that in the network by having a gateway that does that translation. So those are some things that I'm excited about with integrations. But again, you're running this in AWS. So like every AWS thing is available to you. And we add integrations. We have a storage driver as well for EBS volumes. If you want EFS for NFS style, mounts, it can be like mounted to multiple pods. There's plenty of people that do S3 from the pods, which is still HTTP, but I've even seen some people use like fuse drivers to like make it look like a block storage because S3 is multi-AZ. So they're like, oh, well, then I don't have to failover. I'll take a performance hit for, availability sort of thing. So there's all those things to consider when you're running this in Amazon, because again, it's just, you have all of AWS available. And even with some other open source projects like ACK, AWS controllers for Kubernetes is a native way to like provision some of this stuff inside of a Kubernetes cluster. So it makes CRDs for things you might want that are outside of your Kubernetes clusters, like an S3 bucket or ECR repo, or even Lambda functions. And you can define those things as CRDs, and you can see that's like the entire stack of what is used in your Kubernetes cluster by looking at just the Kubernetes API, instead of needing to say, oh, here's my pod, it's in Kubernetes, here's my deployment, but it also depends on this Kinesis stream. Instead, you can say like, oh, well, describe the Kinesis streams for me. Oh, here they are. I can see that one's the provision, that one's healthy, whatever. Oh yeah, that pod uses that Kinesis stream because that's, the app needs it for whatever reason. So some of that stuff is really interesting, how we're pulling some of the AWS stuff, like you have it available, but we're actually pulling some of that into Kubernetes itself and making it more native for the workloads. Already, like I said before, the load balancer controller adds more features to just make it more Kubernetes and AWS native. But storage drivers, controllers for network, all of that stuff is there, and it's again open source, and you can use them in ways that however you want to. If you only want to talk to the Kubernetes API, you can actually do that in a lot of ways, which is, I think, is really cool, because I love being able to have that kube control commands and seeing the CRDs, and I'm used to parsing that output. I love that. I've used the AWS CLI a ton in the past, and I still use it today. But also like just switching those tools, sometimes that context switching pulls you out of like, okay, how does that connect to this? And being able to debug things and deploy things a lot faster when you can use one tool and one API.
Yes, absolutely, absolutely. I think that on the networking side, these are the wonderful details for me, because the people had this kind of issues in the past, like of the networking and the pods having not enough IPs they can get up. So I think the team is working right now on these kind of things. And also I think, as you mentioned, there are all the things are available for the integrations with the AWS console. When you go take a look at that, I think might be, I don't know, I think there are some CNI plugins already available if you want to pick and choose for those plugins inside your Kubernetes cluster. We are all things about the eBPF noise is getting heavier and heavier every day. Cilium or Project Calico, I think these are integration might be coming up in the future as well. So I think we talk about from the Kubernetes cluster point of view, we talk about the project, Porter Rocket, the project, that the simplest way to these kind of things. We turn about networking and runtime, all things. I think another topic I think that's really interesting for the people who are using Kubernetes is called the multitenancy or multi-tenant Kubernetes cluster. So I think if somebody is using Kubernetes today, and tell us about, if people are new to the multi-tenants, explain to us what multi-tenancy is, and tell us about, if you are using a Kubernetes EKS, how to do multi-tenants, how to set up multi-tenant Kubernetes clusters in the AWS, in an EKS side.
I think a lot of people look at multi-tenancy and they say like, I can't run my app with that other team. Like I don't want to, like, for whatever reason, like no, we don't like them. We can't have their app in our cluster. And that, like, that's like an organizational problem. That's not necessarily a technical Kubernetes problem. That's just like, no, like, how was your app running before? Like, it was probably on a flat network on, VMs that could talk to each other. Like, all this stuff was there. The only difference was like the isolation boundary was vSphere or something else that was, like, oh, well, like if they were using all the performance, like my app didn't get hit. It's like, actually, sometimes it did. Like, people don't realize that, where this is the same thing. It's just different boundaries for a lot of it. So I think a lot of companies could get away with multi-tenancy in a default Kubernetes instance. The problems become when they need to upgrade Kubernetes, right? Like when I had vSphere, when I was a vSphere admin, when we moved from one version of vSphere to the other, like we always had to migrate all these apps, and we're like, oh, everyone, you got to move your VMs, because I couldn't migrate the VM directly. I was like, oh, you actually have to install the app over here. I gave you a new VM, whatever. And there was always like the handful of people that were like, I can't do it. Like, I don't have time, or the new version has a bug or something like that, where there's like, oh, like a laggard of, 3 or 4 apps that are like, well, we're going to run this old vSphere cluster forever until they can migrate off. And that was a problem for, historically in infrastructure in general. Like I had physical machines. I'm like, I need to retire this box. I cannot get support for it. The hard drives are failing. Please move your app. I'm like, well, like I can't because the new version of the Linux kernel, like all these excuses. And in Kubernetes is the same thing, where in this case, the problem for a lot of people with Kubernetes is Kubernetes has faster upgrade cycles, right? Like my hardware used to have like a 4 to 6 year life cycle. I'd run that thing for a long time and it was fine. Apps could stay on it. vSphere, similar story where I was like, I could run vSphere for easily 4 years and never have to upgrade. Kubernetes has a much faster upgrade cycle, and support is typically 1.5 years, maybe 2 years. They've slowed it down recently for releases, but still, like you have to upgrade this probably once a year. If you want to stay up to date, you're doing once a year upgrades, which means there's migrations. And a lot of times, to me, the biggest concern of multi-tenancy is being able to do a migration. Because once I can't upgrade the cluster, once I can't move people off of an old version, that's where I actually have a problem. It's like, oh, well, now I have this 1.16 cluster still around. Now I have this old version of Kubernetes that I can't upgrade because the app required something that got deprecated in a new version. And so multi-tenancy to me isn't actually a concern of like, my app can't run with their app. It's more of, how do I keep these things going over time? What does the day 2, what does the day 365 look like? A year later, we've moved all the apps. Now where do they go? It's not usually a concern if people aren't running, untrusted code. Everyone at the company hopefully is writing code that everyone else trusts, is doing the right things for the business. And in that case, it's like, oh, well, maybe I don't want to share resources, or I need some other features. But really, it's about that, like, how do you do day 2 operations? And that's where multi-tenancy, to me, comes in as most important. And in that case, you have to decide, right? Like if you have forward-thinking, people that love developing on the newest thing, like maybe they share a cluster. If you have multiple, needs for availability and you need to do multi-region, or some things could do 1 zone, or some things need like 5 zones, like you depend on those things depending on what the app requires. It's not so much of a, oh, like I don't want to share. I reread the Borg paper from 2015 last night, and it was fascinating to me reading, like, this paper was written 10 years ago, I think 10 years ago. And their isolation boundaries were chroot and C groups. Like that was it. Like they didn't have it. There was no containers. There was nothing else like isolating between these workloads. And these were huge multi-tenants shared clusters at a Google scale. And I was just like, well, that's fascinating. They didn't need that then for as big as they were. And I think a lot of people get hung up on this, like, I need my own cluster because I needed my own server. And so that's just how it is. And in a lot of cases, again, workloads can share. It's just a matter of like, can you work together to get things off of the cluster and move things forward and make it easier? And containers are great at a lot of things, but when you start to integrate more into the Kubernetes API, or you depend on like a very specific feature, or add more controllers and operators, like that's where you're like, oh, actually those things are kind of hard to upgrade. So what do you want to put outside the cluster? Make it a managed AWS service, or again, put Grafana and Prometheus outside the cluster. You don't ever have to worry about what Kubernetes version that lives on. It just needs to talk to the right Kubernetes API, and then just put your workloads inside the cluster. And those are areas that a lot of people just are concerned with. So for me, it really is about like figure out how fast you can move and who you trust. If you need specific resources, which again is, I guess, kind of a thing that people are like, I need GPUs. I need a different size of nodes. I need something, extravagant or something. Like I want the Graviton 2 instances, something like that. You can mix those in a cluster. Like a lot of people don't realize that too, where you can either set up separate node groups inside of a single cluster and say, oh, well, here, assign your, workloads to use a GPU, and it'll get a GPU based on that node. We have another open source cluster scaler called Carpenter that I've been playing with, and it's really exciting. Carpenter.sh is the site, and you can run it now, which will pick instance types for your workload, like direct one-to-one of like, hey, if you say like, I just need a GPU, it'll just go find a GPU instance and spin it up in the cluster. Like you didn't need to pre-assign a node group. You didn't need to do anything to the cluster ahead of time. It does it on demand for whatever your workload needs. So you say like, my workload needs Grabber, workload style instance scheduling for how many workloads you have and the size. So it auto scales the cluster based on those needs. needs. And it's a really interesting thought experience to me of what does multi-cluster or what does multi-tenancy look like when every workload can automatically get the type of instance it wants on demand. And I actually could put more people, more applications in the same cluster when that's the case. And I actually, if the reason to have multi-cluster is, to separate those workloads, actually, no, you can do that too. So those are all different areas of like, I'm excited about in the future where this is getting easier and easier to share some of these clusters. And really it's just about like, how do we know, what do we want to put in Kubernetes, what to keep out of Kubernetes, and how do we upgrade it?
Yes, absolutely. I think wonderful explanation to multi-tenancy. And I think that's a wonderful topic. And I think people are getting in a lot of attraction to the multi-tenancy architecture as well. I see the tool from the Loft, the virtual cluster, that's give you the virtual cluster in the Kubernetes, so you can share or do this kind of stuff. So we have an episode with, I think, Rich Borrow in the CloudNativeFM. Hopefully when it's published, I will share the link with you all guys. So I would talk about wonderfully, and you explain all the things in a very precise way, and I've learned a lot during the conversation. So tell us about the few stuff before I letting you go on the EKS security side of things. Tell us about your opinion on how to secure the secure EKS cluster and some best practices around securing the Kubernetes cluster on the public cloud as well.
Yeah, I mean, that goes right back to what we were talking about earlier of shared responsibility. If you're, if you need all the access, then it's possibly less secure, right? Like if someone's in there poking at etcd, then someone can see all the data, they can modify things. And so having managed service allows it to like, hey, no one actually can see this. And this is a great security boundary for any users that we're not worried about them, getting a shell on a box they shouldn't be on. But then also to the other side of like the workloads, you can't just like assume, my workload is secure without securing the OS and the node below it, right? So like that's where like BottleRocket comes in, and we can say, oh, BottleRocket, actually, we can secure that OS, because that is always a concern for people where they say like, oh, well, what if that container like, breaks into the host and then I can see something else? It's like, well, yeah, but in a lot of cases, like we can apply some defaults on SE Linux. In BottleRocket specifically, there's actually 2 container runtimes. So your workloads run in a container inside of, not Docker, but it's a container D. They have a container D for your workloads and a container D for the host OS. And so you can't actually talk to each other. So if a workload got out of its workload, it can't do anything on the host to like spread somewhere else, and it can't access things that the host might actually have. And so I think it's a really neat security model of, oh yeah, we can just like isolate these workloads even further and isolate those to SE Linux as well, where it's like SE Linux will stop them at the kernel level to like try to get out. So if people say I need security, but they don't look at the host OS, like maybe they don't need that much security. So like there's a level there of what do you actually mean by, is it secure? And it's like, yes, like your workload in a default, setting is probably not secure. You need to add some security constraints and policies. And even at the network level, there's, network policies aren't around anymore, but there's other ways that you can apply rules so that like your workload can only talk to itself or talk to the things it needs to, whether that's through a app mesh or, some service mesh or something else. Like there's ways you can do it. How much you need is really up to you and in your workload. And again, I think that a lot of companies aren't running untrusted code. A lot of them share, responsibility in like the uptime of the website or the app or whatever it is. And so they're not nefarious and they're not going out there and trying to break things. So really it's about like, what if, your application gets hacked from the outside? What could that person do with it? And those are the real concerns. It's not really like, someone else doing it on purpose. And so being able to isolate that and say like, hey, if this, you can have runtime security. Falco is a great tool where it actually like looks at, hey, if anyone ever gets a shell on one of these containers, like just throw it away. Like just don't let them do that anymore. And you can alert on those levels. So there's a lot of really cool tools in this space for scanning the containers, but also scanning it at runtime and saying like what's going on. At the pod level, you always need inside of AWS, you're going to have a service account. You're going to have IAM responsibilities of like what the pod's talking to. And those have evolved over time where they've gotten a lot more secure. And in a lot of cases, the defaults have gotten a lot better. Some great people in the community have been really vocal about like, this isn't secure by default. So let's make it not necessarily like the most secure, but more secure than it was for a majority of people. And I think bringing in those same defaults is a great way just to like level up everyone and say like, hey, by default now we get app armor policies for pods. And like, that's a great option just to like have it there. And people didn't have to do anything. If they're on a new version, they get some defaults that are a little bit more secure. So I think those are great. When I look at IAM, there's always questions that I get about like, hey, should I do kube to IAM? Should I do like, how do I get IAM role to my pod? And that was actually a new thing for us last year in EKS, where we have OIDC authentication for IAM for the pod level. So your Surface accounts will get an IAM credential through an OIDC connection that we also host. So we call it IAM for, it's URSA, IAM roles for Surface accounts. That's what it stands for. But it will, the actual, container will get a Surface account based on an IAM profile. So everything in AWS, you can audit it a little better. So it knows, oh, here's where my IAM's coming from. My pod needs to get that. So it talks to OIDC, and then it gives that back to the Kubernetes cluster and says like, oh yeah, I see that certificate is signed by a trusted authority. Here you go. Here's your Service account role with those IAM credentials. So when your pod talks out to another AWS API, it actually goes through that flow to get the correct IAM permissions. So those are things that, like, again, we're just making things more integrated and more native in AWS. If you're running Kubernetes there, it makes it easier for you to not have to say like, oh, I have to go run something else to now get this thing. It's like, hey, in AWS, we have IAM. That's what everyone's using for permissions. That's how we gate any access to APIs. Let's reuse that. It was interesting seeing how we did that for EKS Anywhere, where we didn't have any of those assumptions, right? Like no one has IAM on-prem. So how do we get some of that stuff? How do we know VPCs don't exist on-prem? So we had to use more, native open source tools and integrate those into EKS Anywhere. So like Cilium is our native, or is our defaults CNI for EKS Anywhere. So it's like, well, we really liked eBPF. We really like the performance of Cilium. We got a lot of benefits that we wanted from a CNI from Cilium. So we bundled that essentially as the default CNI. We're working on native IAM roles for pods in EKS Anywhere. So you'll be able to even have your on-prem pods talk out to AWS APIs and talk to resources if it needs to talk to an S3 bucket or, a Kinesis stream, something like that, where it's like, hey, my pod is on-prem, but I still need some of these cloud resources. And that's a great way to be able to do things in the same way you do it in a fully hosted EKS cluster in AWS.
Yes, absolutely. I think when we're talking about the security of the Kubernetes, we're talking about the cluster, container, code, and the cloud. And we see that a lot of innovation comes up in talking about how to secure the communication between the pod, how to secure the cluster, how the apps that's running on top of it. So I think it's been a 24-hour, 7-day job. And it's an everybody job. It's not a one person who have come up, because Kubernetes is huge. And if somebody's not writing a secure code, I think whatever you effort put on, you are at the end of the day is absolutely unsecure by default if you're not writing the secure code.
And I mean, I can't tell you that like any code I've ever written was secure, right? Like that's just like I always assume every line of code that I write is insecure for some reason. And so yes. How do I secure that beyond whatever code that I wrote? And that is important. And that's where we get some of those controls of like, how much security do you need? And what tools do you want to bring in to say like, actually, this is very critical because it's handling payments or, customer data or something like that, where it's like, actually, this needs the most security. So let's add every layer there and make sure that it actually is worth the time to go into and say like, this needs to be as secure as possible. But like for my demo web app, it's okay. Like if someone looks at my code, is like, oh, actually, like it doesn't have anything. There's no data. There's no nothing. It's a static website. Whatever the case may be. Like there are some things that don't need that level of security, as long as you can make sure that it's isolated and make sure that like you're not leaking IAM credentials or something like that.
Yes, absolutely, absolutely. I think right now we have the tool available. I think that's wonderful. The Falco, as you mentioned, is wonderful. The eBPF on the Cilium networking side, they have done a wonderful job on removing the skill container vulnerability. These are wonderful tools already in the market right now, and I think that a lot of the people are doing investment in design the container images when they move from one place to another place, or when you push the images from or pull the images from the server. So I think the supply chain security is right now the hottest topic in the KubeCon LA this year, and everybody's supply chain. And we have talks with Dan and Matt on this show as well, so go check that out as well. I think we always talking about the security is once again the shared responsibility of the team as we push the code in the cloud. Is it the shared responsibility between the AWS and the user who are using your services and deploying on top of it? So I think we talk about a lot of stuff on the container, how container, Kubernetes, EKS Anywhere, EKS distro. We talk about the networking side of things. I think we cover a lot of ground on the EKS side. So next thoughts on tell us my audience about, because Kubernetes, we all know that it's a giant, it's been a humongous topic, and people are getting new into the Kubernetes. What should they do now to learn that Kubernetes, a technology in an effective way? Because you can't ignore it as this moment of time. What happened in future, we doesn't know. But in this moment, you can't ignore it as I see. So tell us the tips on trick how to get starting with Kubernetes effectively.
It depends on what problems you're solving. Like, I mean, if you want to learn Kubernetes, there's plenty of great ways. Like Kubernetes the hard way. If you actually want to learn like the details underneath, we also have a EKSWorkshop.com, which is just like, let's spin up EKS clusters, let's upgrade them. We have a bunch of different pieces in there on how to, I built one for like how to migrate from a self-hosted Kubernetes cluster to EKS, and with a stateful app and a stateless app. And let's see like what that looks like. And so it walks through like some of those steps. There's a ton of other, great ways to like do very specific things in it. If you're like, I need to solve this problem, there might be a module for it in EKS Anywhere or EKS Workshop. But if you're really looking at like, what problems are you solving with Kubernetes? Like what pieces do you need to learn? Really depends on what you want to do with it. If you're a machine learning expert, like you probably don't care about most of the Kubernetes stuff. Like you want an API with Kubeflow or something. You want something on top of Kubernetes that is actually solving the business problem or your career goals, right? Like that's fulfilling there. If you want to be a Kubernetes expert, if you want to be an infrastructure engineer working on Kubernetes, then run clusters, like run clusters that are on your local hosts, that are, done the hard way, that are manually configured. I know David has the clustered series on YouTube, which is a great resource for like seeing how things break, right? Like people go in and on purpose break these clusters and then just try to fix them. And like that's, to me, was the best way that I started learning things. I wanted to learn how schedulers worked in Kubernetes. So I wrote one in Bash, and like that was one of my learning experiences years ago, where it's like I spent, a couple evenings and I like ran, it wasn't Kind at the time, I think it was a Minikube locally. And I said, hey, what does this take to actually run a custom scheduler? And I was like, well, I want to do it in maybe not the best language, but something that like I knew I could do pretty quick. And I was like, I wonder if I could schedule a pod in 100 lines of Bash or less. And I was able to. And that was really eye-opening for me to learn, oh, actually, like, this scheduling a pod is just like this workflow. And once you understand some of the workflows of like how a replication controller works and how different controllers in Kubernetes work, it made a little bit more sense to me. It's just like, oh, this new controller, maybe I've never used it before in the past, but I have a feeling it works similar to this other controller. And it does the same workflow of like, get me, the thing with this label, let me apply a change to that label and put that thing back with a label. And that's like that flow of modifying resources inside of Kubernetes was pretty natural once I got the hang of it. And so if people are really like, I want to extend Kubernetes, I want to build on top of Kubernetes, or I want to operate Kubernetes, that really is like, okay, you can dig in deep and learn those things. I learn by building on it and doing things, and everyone learns different ways. But really ask yourself, like, what's the next goal? Like after you learn Kubernetes, then what are you going to do? Are you going to go get a job operating Kubernetes? Are you going to like have open source projects, whatever it is that you're trying to do, always try to look for the next thing, because that'll inform you a little bit more of how deep you need to go. And if you're like, I want to operate Kubernetes, and then you start writing eBPF code, it's like, well, maybe like you should look at something else. That if you really want to do eBPF, like go look in a different direction of observability, go look at networking levels, go look at like security. There are other areas of Kubernetes ecosystem that might be a better fit for what you're interested in doing. But if you really just are like, I just want to run an app, to me, like write the app and start without Kubernetes and then go backwards. Like we have App Runner that we launched earlier this year, which I also worked with, which was great because there's no Kubernetes involved. It's like, I have a container, run it, give me a website. Give me a web endpoint with TLS and just run my container and scale it for me automatically, all that stuff. And so seeing that experience versus, oh, I have an app, now I need to write some YAML, now I need to do something else, now I need to like understand where the boundaries are, like all that stuff of like ownership models of like, hey, if you just have an app and you just want to run that app, maybe you want Lambda. And maybe that is a better solution. Kubernetes is still here. It'll solve different problems for you. But I always try to tell people, if you don't have a Kubernetes problem, don't use Kubernetes. There might be better tools for the job. I used a lot of ECS in the past. When I was at Disney Plus, we have a bunch of reInvent talks, how Disney Plus uses ECS. I operated a lot of large scale ECS clusters that solved all of our problems, and it was fully hosted for us. I didn't have to worry about the control plane. I didn't have to worry about some of the other things. So we were able to do more with less. We had less people, we had less concerns and less security boundaries that we had to actually worry about, because a lot of that was managed for us. And so it's not even like a, if, either or, like just like figure out what it is that you need and then solve that problem. So again, Kubernetes ecosystem, a lot of people want it. I love the API and the community of it, but also just pick and choose what it is that you actually want to do.
Yes, absolutely. I think these are all awesome tips for everyone who are listening to us. And I think that RockOJ clustered is one of the great places because breaking the cluster, I think you learn a lot. We can see how other people's break clusters, and it's really, really a wonderful live stream. So I think you find the link here in the chat and you go explore that channel if you are learning about. And I think the wonderful tips and the tips that I think we take home is understand, set a goal, what you want to do after learning the Kubernetes. I think this gives you the most informative learning experience. That's if you want to do the Kubernetes cluster or operator or Kubernetes developer or the security specialist or somebody else. So I think go explore first what you want to do after completing the Kubernetes courses and learning experience. I think that's a wonderful tips. So I think before I let you go, wonderful talking, wonderful knowledge again during the conversation. So tell us about, because this is question I ask frequently the people. Let's say the Kubernetes is offered as a school, in the school syllabus, Kubernetes is offered for you. Do you pass that course?
Oh, and what level is this? Is the class, I guess?
Oh, good. Let's assume is a not a junior, not so higher, not so. It's a junior level class, like a 5 to 10 or.
Like, I mean, I have my Kubernetes administrator and application developer certification. So like those were really difficult for me.
Yes,
like
absolutely.
I failed the application developer the first time. I ran out of time, and I was like, I don't know these problems, because it wasn't something that I was dealing with on a day-to-day basis, because I was running Kubernetes on-prem and I wasn't an application developer. So I was like, oh, I actually had to learn quite a bit more to understand what app developers were dealing with on top of Kubernetes, because I was just an operator. And so at the operator level, like CKA, I found I was doing it the hard way on-prem. And so like I knew all of the bits and I knew the flags back when I was running Kubernetes on-prem. I was just like, this actually made a lot of sense to me. When I went to application developer, I was like, some of this is foreign, so I need to do more work here to learn more. And my goals were, again, looking forward 2 steps was, I didn't want to always be a cluster admin, but I wanted to be that like platform level in between the application developer and Kubernetes to build something that made it easier for the application developers to use Kubernetes. And so I needed to understand what pain points they had. And that's where I started deploying my own apps on top of Kubernetes, and not just deploying them, but actually living with them. Because once it's existed for more than 6 months, things change. And as the Kubernetes API changes and as storage, whatever the case may be, like applications kind of have shelf life. Like they start to devolve after a certain period of time. And even in Kubernetes, when I can just refresh the pod, like there's still things that are like, oh, I actually have to maintain some of this. I have to keep this up to date. I have to figure out new ways to like add RBAC controls or something else into the application. So I wanted to understand that for what it was like as an application developer, and then be able to like say, hey, how can I like hide some of the Kubernetes stuff? So you don't need to worry about that, because not everyone should be a Kubernetes expert. But it's good to be able to build those bridges between the application that the business requires and needs and the infrastructure that it depends on.
Yes, absolutely, absolutely. And I think the CKAD, CKA, CKAD, and CKS, I think these are the toughest exam. But I think when you have the concept and patterns clear, I think, and you have worked on the lot on the bash shell and these kind of script, so you already passed these kind of courses. So that's an easier question for you. So a tougher one. So let's say if I ask you to teach Kubernetes to the people, is a how do you take that challenge, or how you look at this challenge of teaching Kubernetes to others?
Yeah, I love that challenge. I do that challenge every day. And that's like why I took the role at Amazon. Was I liked being able to teach people, but I like teaching people in slightly different ways than some people. I like to teach the way I like to learn. In a lot of cases, that's with props, and that's with visual aids, and that's with whiteboards. And I like to draw things. And we have a show at Amazon called Containers from the Couch. And my team we have guests come on. We try to teach different Kubernetes concepts. Most of the shows that, like, if I'm in charge of teaching it, will have some prop involved, and I'll bring in something for a visual aid, because that's how, when I thought of it, I'm like, how does security work? It's like, okay, well, how does a door lock work? That's secure, right? Like that's like, for me, like a physical like thing. So how would a door lock be similar to RBAC? And I'm like, okay, well, how can I tie these things together and make it more easier to understand for people? And I remember doing I did a Bottle Rocket episode, and we were talking about upgrades. Like, how does Bottle Rocket do this, like, partition swapping for like how it boots and stuff like that? So I had like bowls of cereal and 2 different types of cereal. Like, here's the new version of Bottle Rocket, here's the old version. And as we pour it on either side of the bowl, like that's when it actually like flips over and we boot to the other side. I think it was like Cheerios and Fruit Loops or something. But to me, like, that was just how I liked to learn things. I love, watching shows that have a very visual aspect, but still teach me something. And so I'll try to teach 1 or 2 things, which is some sort of prop and a visual aid. And that's what, like, I really like to do. It's even better in person. I did a KubeCon talk years ago with like balloons and a spreadsheet, and we talked about how Kubernetes worked, and we had people that were the nodes. And like, to me, that, again, that's just like, I like to be very visual, because that's how I remember things. And if I can make an analogy of like, oh, what's the pod doing? Oh, the pod is like, before it runs, like, it actually has to like set up storage, it has to set up security, it has to set up something else. I'm like, okay, what if I was building a house? Like, I need a foundation, I need some walls, I need insulation. And like, we set that stuff up ahead of time, and then we can actually live in the house. And that's where, like, I draw these analogies to real life and what's around me in the physical world. And that's how I like to show it to other people. And to some people it resonates great. Some people just like, just show me the code and I don't care. I'm like, that's great. Other people can absolutely teach you that way. But my way is going to be just a little different sometimes.
Yes, absolutely. Absolutely. I think that's a great tip, because the way you the way you learn about the thing, I think when you explore the same way, the way you learn about these things, and you deliver in the same way that you learned during your time, I think that's easier. And I think illustrations are using in the Kubernetes brain a lot. I see a lot of diagrams, a lot of cool animated stuff showing you what it is actually, because animations are really easier to understand, and these are the documentations, the paragraphs are so long, and it's take, I think, months and years to go through that paragraph. Illustrations are being very easy. So
yeah, and I definitely learned that at Disney Animation, where like just moving a picture slightly can change completely how I perceive it. Right? Like, I could have a paragraph of text and like, this says the same thing, and then I could draw you like 4 lines, and like, that does the same thing, but it still doesn't connect. And like, and then I can make the lines move just slightly, just like, hey, this one moved here, and you're like, oh, I get it now. Like, it's amazing how our minds can like connect just a little bit of movement to like, oh, that's what it's doing. I understand it now. Like, my eyes glaze over when I see a big diagram. I'm just like, I don't get it. Like, don't show me the entire finished diagram. Show me one piece at a time, and then how the things talk to each other, and animate it that way, and then show me where it goes. And I used to never teach this way. I always tried to teach like the way that was like structured of like how classes taught me. But then I started learning like, oh, actually other people like the way I like to learn. Other people like to learn that way too. So I'm just going to keep doing that. I'm going to teach people the way I like to learn. And I found there's more people out there that were like me. So it was great just to be able to keep doing it and say like, hey, I learned it this way. I'll teach it that way. And maybe you'll learn it too.
Yes, absolutely, absolutely. I think the illustrations are really the wonderful way to learn about, because some of the people have like some kind of a disease learning or reading disorder, like the dyslexia is a disease. We have a reading disorder. You can't run the long paragraphs, but if you animate something stuff, like I see the logo of the Docker. When I first learned about the Docker, I see the logo. It's give me the feeling what it is actually. Is it really difficult to understand what the Kubernetes logo is? But for the people, like for everyone, even my mom can say that's logo is depicting us. It's spun up containers and it can manage the containers. So I think that's illustrations are really easier to understand. And I see people who are teaching about Kubernetes, they do the heavy investment on these animations and these kind. And if you have experience like Justin of Disney, I think that's easier for you to build out these wonderful animation while learning and teaching about the stuff. So before I let you go, wrap up the discussion and tell us some two or three tips and tricks so we can be effective with running our apps on top of EKS.
To me, it's it's just Kubernetes. And so you can use all of the ecosystem, but lean into what AWS provides. If you don't need to run your own Kafka, use Kinesis. If you don't need to, run MinIO for your own like storage, like use S3, obviously. Like there's certain levels there of people, if they need the ownership, they say like, oh, well, I have to run everything myself. It's like, actually, you can get by with a lot of managed services and you'll go a lot further faster because you don't have to always constantly like, oh, I need to upgrade that thing. Oh, there's another CVE. Oh, there's a bug in this one. So like being able to rely on some managed services and just offload some of that concerns and some of that work to your provider is a great way to go, because you can do a lot more and not concern yourself with everything, because no one is an expert in the entire like Kubernetes code base. Like you even look at people that started Kubernetes, they'll frequently tell you like, I don't know Kubernetes anymore. It's moved too fast. There's too many people. The ecosystem is too large. I know this piece of Kubernetes. Like, this is the sliver of the thing that I went deep on and I understand, but the rest of it, like I can maybe go a little bit further of like how I interface with other things, but it's the same thing with your apps. Like you don't have to understand all of everything. Like just focus in on what your application needs, what problem you're solving. And if you're doing it professionally, really focus in on what the business actually wants you to do. And if the business isn't saying like, I want you to be a Kubernetes expert, like I need you to build a login portal, like don't go like the other way. Like just like listen to what it is that like you're doing professionally and what you want to do. So that's really like the main thing that I would think of is like, don't try to just say like, I have to understand it. It's okay if you don't understand it up front. It's okay if you don't know all of it. You can know your piece of the pie and still be very effective at what you do. And so that's like a huge win that I think as soon as you can focus in on things and say like, oh, I'm gonna use S3 for that. Oh, I'm gonna use RDS for that. Oh, like it'll get you so much further and you don't need to be a DB admin or whatever. So that's like my main tip. And then second is just like, if you can lean on the ecosystem and existing controllers and resources that are out there in the Kubernetes community, do it. Like you don't have to write your own. Some people always are like, oh, I need an operator, but I need like this tweak on this other operator that exists. And so they go and write it from scratch and it works great for them for 6 months. And then 6 months later, like 2 people left the company, they don't want to, change to the new Kubernetes version. And then they're like, well, now I can't upgrade my Kubernetes. I can't use this new feature because I built this operator from scratch. It's like, actually, like maybe contribute back to the original, like figure out like if you can use one upstream or change your app. If you can redesign your app in certain ways to make it fit a little better, that's a bigger win. Like when I was running Kubernetes, or when I was running the ECS clusters, like we didn't allow people to have stateful apps in the clusters. We just said, nope, no storage. It's technically possible in these environments, but we said no. And it allowed us to do so many more things because we just said, hey, you architect your apps with no disk storage. You can call to S3, you can call to RDS, you could do whatever for your storage, keep it outside the app. And once we told people that, it was so much easier to do cluster upgrades. It was so much easier to like change some defaults and redeploy things. It was so much easier to like patch CVEs. All of that stuff just got so much easier. And I didn't realize it at the time that that decision was important. We're like, actually, people wanted stateful. They wanted workloads that had disk storage, but we said no, because we're like, we can't support it right now, maybe ever. Please architect your app another way and come back and we'll give you these other things as value. And they still, like the other value adds of security patching and all that stuff, they still wanted that. So like, actually, no, this is so good. I'll just put my state somewhere else. And it worked great for us in those environments too. So maybe changing your app, if you do own the code for the app, is a better way to go than trying to like take everything and bring it into Kubernetes.
Yes, absolutely. I think that's a wonderful tip. Focus on the problem you already have and see what you are interested about in Kubernetes, on networking, storage, container runtime interfaces, or the container itself. What your interest inside the Kubernetes are, and if you find any difficulties or moving around the road on container networking side or the EKS or other cloud providers, or check at the community. We have a wonderful, I think, speakers around different technologies available. I see, and me and you always understand this because we have a CNCF, and if you build down some solution, the next day the amount of resources you have on that particular technology, that's awesome. I think that kind of the 5 to 6 year long project like Kubernetes, the amount of appreciation, the amount of progress it gets, I think that's huge. We never seen that before in a very shortest amount of the project that can expand widely in the global ecosystem. And plus the ton of the tools available, and they have a wonderful documentation support, a wonderful community support, and we have a lot of people who can talk about with these kind of stuff. So I think we are into the good community, and I'll always tell my other people that we can't learn 16 or 15 different tools in a day, but we can see what those tools can do at this moment of time by following those people who are working on these technologies, on these tools. So I think that's a recommended approach for everyone listening to us. So tell us, on the Cloud Native Islamabad side, we can have a Justin on the webinar, where we can do the EKS Anywhere or EKS on the Amazon. We can do a session on these kind of stuff. So your comments are vital for the, and tell us what are you currently facing the problem into the AWS or EKS side, so we can do a hands-on experience as well. So wonderful time with you, Justin. It's been you are the first guest from the AWS side, and hope to catch up you again and doing some hands-on experience on EKS side. Thank you very much for your time. Stay safe, stay healthy, everyone. Bye-bye.
Hi, thank you.
The Kubernetes, what you think still missing in the CNCF ecosystem, what you still think need to be improved in the moving forward, and what you think after the 2022, what is your primary goal, what are your current goals set, what we expect from you, what your goals are for the 2022.
That's such an extensive question, to be honest. What's next for Kubernetes community and the cloud native community? I think so one thing that I've been working with in the past couple of months is have a cloud native maturity model. So and why is this necessary? Because if you look at the CNCF landscape at the moment, there are hundreds of tiles and different projects and organizations that are affiliated with CNCF, and it's just overwhelming to look at it. And if you're an organization that starts on the cloud native journey, you have plethora of choices when it comes to networking. You have so many choices if you want to do storage. You have so many solutions for service mesh. Like you really kind of, it's an expensive space, and it's very difficult to kind of make one decision and know that's going to be a good decision. Like the short answer, there is not one kind of gold, silver bullet for everything, or like a golden path. But providing some guidance can be extremely useful. So not providing solutions, but providing some guidance of how can you maybe choose the best tool based on where you are with your organization at the moment.